Okay, guys, so I forgot to show you this problem, which you will see on your test tomorrow. So I'm going to go through it really quick. So the problem says that a student has started a lawn care business. He charges $15 an hour to mow lawns and $20 an hour for gardening. He's still in school, so he's only allowed to work for at most 20 hours per week. And his goal is to make at least $300 per week. So the first problem is asking you to create a system of equations or inequalities that models the situation, and to define the variables that we're going to use. So first off, let's look at this graph that we have here. We see that the x-axis is talking about the hours of lawn mowing. So we'll just use x to represent mowing lawns. And then the y-axis is talking about gardening. So we'll use y to represent the hours spent gardening. So we know he's charging $15 an hour for lawn. So we're going to do 15 times x. And then we know he's charging $20 an hour for gardening. So we're going to add 20y. And we know that the most, or he wants to earn at least $300 per week. So that red inequality at the top represents that system. The amount of gardening he does plus the amount of mowing he does, he wants to earn at least $300 per week. And then also it says that he can work at most 20 hours per week. So X represents the number of hours mowing, Y represents the number of hours gardening. So adding those 2 hours together, they have to be less than or equal to 20. So that is where you get the second inequality in that system. So the two inequalities in red represent the two systems that we'll be working with in this problem. And then we always want to make sure that we convert our inequalities to slope-intercept form. So the two inequalities you see to the right are simply the inequalities converted from standard form to slope-intercept form, so that when it's time for us to graph, we can do that easier. So next, it says the graph shows one of the relevant equations in the situation. Draw the graph of the other relevant equation. So if we look at this, we see that the y-intercept for the graph that's already there for us is touching the y-intercept at 15. So we should know that by looking at that graph that this line represents the first inequality, because you see that top inequality in purple, the y-intercept is 15. So now all we have to worry about is graphing the second one. So you would simply graph that. Your y-intercept is 20, and your slope is going to be -1/1. So you're going to plot 0, 20 on the y-axis, and then you're going to go down 1 and to the right 1 and continue to do that until you have a full line that touches both the y-axis and the x-axis. And you can also, instead of plotting all of those points, if you want to simply find out what the x-intercept is going to be, just plug in 0 for y and solve for x, and you will find that as well. Or you can just use graphing technology. But to do it the old-fashioned way, you would plot your y-intercept first, which again is 20 or 0, 20 on the y-axis, and then continue to plot points based off of your slope, which is -1/1, and go down 1 and over to the right 1 and continue to do that until your line touches the x-axis. And then you'll do your shading using the 0, 0 test for both of those inequalities. And once you complete that and find your overlapping area, it's asking you to tell me or show me all the points that show the number of hours he can work at each job and meet his goal. So once you identify your solution area, any point within that solution area would work for this system. That is it.